Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers. Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a light classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Okay, so is there only one person who has logged on to LMS? What about the others? Out of the, I think 97 people who have joined. No one is using LMS? The 2 people are using LMS, 3 people, 2 people, right? Who else? 3 people, who else? So Ammar, you can see there are a couple of questions. Can you please take them out? Okay, so there are 3-4 people only who are saying they're using LMS. Okay, Ammar, there are 2 questions. Do you want to take this up?
I replied them into the chat box.
After completion of program, if we have any query, then where to contact? Can we enroll for more programs at a time? So these are the 2 queries.
For future reference, email ID is egil@xlr.com. And yes, those who want to enroll for our future program, you're welcome. So the website.
So how do they do that is what I'm asking. They're asking, I think.
Sorry?
How can they enroll for more programs?
From our webpage, EDL free course webpage.
Okay. Do you want to share the link of that webpage here?
Sure.
So I think, Bhavana, are you clarified with what to do? You have to write to XLR after the completion of the program if you have any queries. And Amar sir is sharing this link, you can see. You can register for this based on your convenience. Okay. So some of you are saying 7 to 9 is not convenient, right? How many of you are saying 7 to 9 is not convenient? Because that was one of the things I heard during the program. Is 7 to 9 a convenient time for everyone? For future programs also, or you want 5 to 7? Okay. Okay. So Ammar, you can make a note that some of the students, I think, prefer 5 to 7 timing, and some of them prefer 7 to 9 program timing. So maybe going forward, you can keep that in mind.
Huh.
Okay. So good evening, everyone. Shall we start with Power BI? It's 7:10. We still have only 108 people. So how many of you are thorough with what we did in the last class? What are the things we did in the last class, guys? What are the things we did in the last class? Anyone remembers what we did on Friday? You can raise your hands or you can put on the chat window. We added a calculator. Yeah. What else did we do? So today we will revisit that. Okay. Other than that, what else did we do? We did only calculation. What else did we do? We did nothing else on Friday. Didn't we create this kind of relationship? We did data modeling, correct? Yes. What else did we do? So we redid some data cleaning also, right? Yes. Yes. Okay. Now what we did, this is the most important. Okay. This is called as data modeling. We did not do user interfaces. Okay. All right. So today we are going to understand data models. This is very, very important. Why? Because you remember we actually have imported data using Excel. Do you think in companies they'll be using Excel data or they'll be using other data also? What do you think? So let's say, okay, suppose you are working in some place like Facebook. Okay, what kind of database they'll be using, guys? What kind of data they will have in Facebook? What are the kind of data we will have in Facebook? Let me change this color. So Facebook will have what kind of data? It'll be good if Redmi 9A, you can follow what I am saying. Text data. Facebook will have text data. What else? Okay. They will deal with text data. What other data they will have with? So I'm talking about Facebook as a platform. What other data they will have? Yes, multimedia data, right? Correct. Pictures, personal data, correct. So login data, right? So what is this data? This is big data, isn't it? Isn't this big data? Yes, this is big data, right? Yes or no? Okay, suppose you are going to work with a company like ChatGPT, okay? What kind of data they will be working with? If you're working in a company like ChatGPT, what kind of data they will be working with, guys? So what ChatGPT does what? Yeah, so you have login data. There is text data, right? Or image data. Then in the background, you basically have to update ChatGPT, no? You've seen ChatGPT version 3, ChatGPT version 4. I think currently it is in 3.5 or 4, right? Right? How will you know? You can go to ChatGPT and check. It's 5.2, I think, the version. Correct? What is server data? What do you mean by server data? Nathaniel Da Silva. What is server data? What does that mean? That is not called server data. Okay, don't wrongly use terms. Server data is not all the data we input. That is called prompt data only. Whatever we input is called prompt data. Okay. And you also have big data when you are updating your models, correct? This is also not called as server data. Okay, any data that is stored is called as a database management system, right? So it's called RDBMS. You don't call it as server data. Correct? So to a certain level, you find this is also big data, right? So tomorrow in your interview, they can actually ask you questions about big data and how data modeling can happen and all. That's why we are going to learn about data modeling in a little more depth. Is it clear, everyone? So let's look at another company, Amazon, right? What kind of data Amazon works with? So you have transaction data, right? Then you have got product pages. Now these product pages, if you see, there are different pages, right? It is in the internet and it is transferred as packets. So it is definitely not RDBMS. So it is not going to have tables and all of that, right? What it will have? It will have something like JSON, internet-based databases, correct? Or it could be Paraquet, which is document-based databases. Okay, these are different ways in which they store data. They don't store data as tables or worksheets. Okay, like we saw, we saw tabular separated columns. We had comma separated values, right? Correct? Yeah, it could have location data, correct? It could have location data, which would be part of your login data, correct? So Redmi, we did know what is big data, right? Who can tell Redmi what was big data? We discussed it, no? I think last week. What is big data? Don't we know what is big data? So big data is basically defined by data which falls under, yes. So it could have voluminous data. When you have huge volume of data, it's called big data. When you have high velocity of data, it is called big data. What is the example of high velocity? Stock market, right? That is also called as big data. What else? When you have a variety of data, it's called big data. What is the example of variety of data? What is an example of variety of data? Anyone? What do we mean when we say variety of data? Yes, multimedia data, correct. So when you have multimedia data like social media, that's also called big data. When you have data which basically needs to have a veracity, that is, this needs to be verified. Like you're doing transactions, right? You're using UPI transactions, correct? This is also called as big data because they cannot afford to make any errors. It's possible that you are paying X person, but you are not directly paying to them. You are paying to Google when you're using Google Pay, right? And then it possibly has a number of vendors and it is paying, right? So when you're using UPI also, it is called as big data. Okay. When you are creating these graphs, you are using, let's say, Tableau, or you are using these online services, which basically produces reports. That is also called as big data. Okay. So maybe some of you are using Power BI online, right? That's also called as big data. Okay. So you can see all these types of data are called as big data. Is it clear? Am I making sense? Okay, cool. So basically, we have to understand that this data modeling, no, where we are creating this relationship, it has not started on air. This basically has been a concept which has been developed since 1970. The initial definition of data modeling was given by Edgar F. Codd, who said that a data model is a collection of concepts. So this is important. It's a concept for describing data structure, data relationship, and data constraints. So what do we mean by that? So if we go back to our Power BI, we have got three tables, correct? One table is worksheet 1, which I have renamed as order sheet. Second table is people. Third table is returns, correct? So this is the data structure. So date orders underscore sheet has got these different columns. Some of these are, so what would be the primary key for this? The primary key for this, primary key is the unique value for this whole column, which will not repeat, which is going to be unique, is basically row ID. So the primary key for orders underscore sheet is row ID. Okay. If you see, it is going to be unique for every column, correct? Then there are number of keys, other keys. What do we mean by keys? Keys are basically columns using which we can connect to other tables. So we definitely have something called as order ID. So basically, whenever you see some ID, these are all called as keys. Okay. If you can only have one primary key, the other keys are all called as foreign keys. Okay. So I need this key to connect with other tables. So we have order ID, we have customer ID, we have product ID, then we have regions, correct? And then we had connected this using order ID only, correct? Are you following me, guys? Maybe you could have gotten states also, you know. Maybe you can connect using that also, correct? So these are all, this is called as what? This is the data structure. So there is a primary key. These are all called as foreign keys. So in short form, these are all foreign keys and you have a primary key. Okay. So what do we call as, why do we need this? We need this basically to connect with others. So this connection is called as the data relationship. Correct? Everyone clear with that? Yes? Yes? And you know that data basically flows. So for each of this row, I'm connecting this row. So you have a many to one relationship, correct? So this direction and this particular connection, as well as you find that there is a constraint. What is the constraint? So you can see that currently I do not have any product ID. Is it possible for us to create another table with all of those relationships? Product ID, I can separate it, yes, but it will not be unique, correct? Because if I basically create another table and I separate it, I will basically, you find that I have got duplicate product IDs, right? In every row in order sheet. Yes or no? So there is a constraint, correct? Am I making sense, everyone? Yes or no? Okay. So this on the whole, this is called as a data model. So the constraints are what? I have got this product key, only this foreign key. Okay. I can only connect in a particular fashion. Currently, I have got products in my orders, but I don't have a table which is enlisting all products. From order sheet, it's very difficult for me to create a products table. Correct? That is a constraint, right? because I don't even know whether the products listed in this orders is all the products. Even if I think that, even if I assume that the products are all the products, I cannot get a unique one, right? Clear? Everyone clear? Making sense? So this is called as a data model. This is an important definition, so please keep it in mind, okay? So whenever we are talking about RDBMS, right? What is RDBMS? Basically, when you are having exactly tables like this, okay? He basically came with this idea. So you also know that these, when I have created these models, right? In anyone knows here SQL? So in SQL, what happens? Basically, only the tables are existing, right? Then you open your SQL software, you basically will you basically create these relationships and you basically write those queries and the output comes. So these relationships in SQL we create on the go in queries, isn't it? Yes or no? Yes. So all that is based on this definition. So that is why it was called as a data model. So you will say MySQL. SQL is how you write queries, but MySQL was what? It was basically an RDBMS. So it is a relational database management system, correct? And you can create data models using SQL, right? So this definition is important. You can write it down or make a note of it. Okay, clear? Okay, so based on what Edgar has said, okay, there was someone called Ralph Kimball who basically came with the data warehousing philosophy. Okay, why data warehousing philosophy came into picture? Now you find this, correct, in a SQL, right? But if you consider a company, over a period of time, what is going to happen? The database is going to expand, right? Suppose, let's say you are a shoe producing company. Then you will have different products. Maybe every year you are introducing new products. Maybe you are retiring old products. So what will happen? Your product tables, it is going to either multiply or you're going to revamp it. But if you look at your transactions, suppose you're going to look at some 10 years transaction, it will also consider, you will have products which have been retired. It will also have products which are new. It will have products which are best sellers. Okay. Now look at the price points of these transaction tables. The price points might have changed for the same products across time. And it is valid, correct? Yes or no? Similarly, it's possible that initially you were available or selling your products in some markets. Now you are expanded all over India. So your markets and territories might all change. Your sales people might change. The regions might change, right? So what you are going to do? It is impossible for you to do analytics on a daily basis. So what you will do? You are basically going to keep your data in a place which we will call as a data warehouse. Basically, it is a server where you are going to keep all this data. Yes? Okay. So now Ralph Kimball. So what would be the different kinds of data? You can have ERP. ERP is what? Basically, you might have a manufacturing place, you might have warehouses. ERP data basically is when you are having physical store places, right? So I am having a store place or I'm manufacturing and I'm putting it in a store place. I am selling to the person. Okay. So the person actually gives me an order. Based on the order, I find out the product and I give it back. Okay. So all this can be tracked using ERP. Similarly, you might also have other kind of data. For example, you might have your customers. You might have your customer table, correct? This need not be ERP. This could be some other software like a Salesforce or something, correct? Yes. Then you might have your employee database, right? So it's possible that you're having different data. Okay. Now, this data warehousing is basically going to be the data where you keep everything in one place so that later, at a later point in time, you can do analytics. Okay, this is the logic of data warehousing. So Ralph Kimball said that I basically can use this kind of star system. What is the star system? He said, I'm going to have one fact table. I think a lot of people were asking, what is a fact table? So basically, a fact table is the table which is going to have all the transaction details. Okay. So whatever is going to happen in the business, like this ERP is going to give me, no, production, sales, orders, right? This is called as a fact table. Now you can see that I have got different data which is stored in the fact table, right? But I can access it using these dimensions. What are these dimensions? So you can see I have an employee table, right? So you can see I have a dimension of employee table here. So this is just going to have employee table. Basis on this employee, I can find out how much did the employee sell? What is the profitability by employee? How many people did they basically access or contact or phone, right? Similarly, you can see there is a sales territory. That is, I think in our table, we have got country is one country only. You have the state, you have the city, right? And then you have the region, correct? So I can basically identify what is the sales by region, what is the sales by state, what is the sales by city. Now I have got these two-dimension table, right? So I can find out that how much did the employee sell in this particular city. I can do that. So one employee might actually have different places to sell, right? So I can find out that how much did that employee sell in the state. Maybe he is selling across states or across cities. Am I making sense, everyone? Is this making sense? This particular schema? This is called as the star schema. Okay. The table in the center, which has got all the sales data and other data, this is called as a fact table. Every other table using which we can extract information is called as a dimension table. Is it clear, everyone? Okay. So Ralph Kimball said that a data model is a structured representation of analytical data. Why we are saying this? To a certain level, this is all business data, right? But you can see I am organizing it in a certain way. This is called as analytical way. Analytical basically means intelligence or the way in which you organize something, okay? So you organize measurable business events as facts. So I have a fact table and descriptive business context. What do I mean that? So these are all filters. I can find out how much did this employee sell, or how much sales happened in this city, or how much sale happened. Maybe I can have another date table also. You can see that. So on this particular period of time, how much did this employee sell in this state? I can find out, right? And how we do that? We do that by using the star kind of relationship. So dimensions will basically have context or filters. These are the filter data. So in Excel, if you remember in the pivot table, we had put some data in the filters, isn't it? For example, we had date as a filter, or we could have returns as a filter, or we could have a region as a filter, or a product as a filter, isn't it? And we are basically going to look at sales, profit, quantity, then returns rate. So you remember we calculated all that? Making sense, everyone? The star schema is very, very important. So please take some time and understand this. And you can see that this particular way in which he has arranged, no, this needs to be accurate, it is consistent, and it is scalable. So it is possible for me to keep on adding employees. I can add another column and I can say that present, not present, retired, or something like that, right? Similarly, date also, I can keep on adding something here. So the fact table is just going to have data, sales, all of that. And I can make all changes or filters or make different context on this dimension tables. So as a result, what happens? I am going to consistently and accurately capture transactions in the fact table. I will bring my context and filters in my dimensions. So it is scalable. Is it making sense? Okay. So this is called a star schema. And you need to remember that in a star schema, the cardinality is always going to be between the, if we consider the fact table and 1 second. Okay, so if you consider the cardinality, right, the dimension to fact table, it will always be 1 to many. This will always be the dimensions, sorry, cardinality. Dimensions will have one single, so employees also, it's possible that I'm going to add employees or subtract employees, but the employee ID will be distinct. So I will not assign the same ID to a new employee. No. So even if, let's say, I have the CEO of the company, in 10 years, the CEO has changed, right? But the employee ID is going to be different. So both the CEOs can be represented in the same fact table, right? So you will have distinct employee who is related to many orders. Am I making sense, everyone? How this works? So please understand, this is called as a star schema. Some of you were asking what is a fact table? So the table in the middle, which is having all the measures, business events, facts, these are called as a fact table. All the context to the business, okay? So what do you mean by context? If I have sold something to another company, right? There was a salesperson involved, there are products involved, there was manufacturing involved, there were people who have basically picked the product from the warehouse and shipped it, right? So many people are involved. All this can be captured in dimension table. Am I making sense, everyone? So consider your car. You will understand that every car has got one unique registration number, correct? But you will also find that a car will have a distinct chassis number. So if you look at the manufacturing data of the automobile, the car is identified using the chassis number, correct? So using the chassis, the company, let's say you have bought a Honda car, right? So you can access from Honda what were the initial parts that happened, which components were changed, why this happened, everything. Because they probably will use this kind of star schema to retrieve information. Is it clear? Anyone having any questions, query, doubts? So I can see only 2 people are active on chat, Bhavana and Sheikh. What about others? See, this star schema is very important. They will ask you. Okay, clear? So write down this definition, note it down. A data model is a structured representation of analytical data that organizes measurable business events as facts. So this is what we call as the fact table, and descriptive business context as dimensions, and defines the relationship between them to enable accurate, consistent, and scalable analysis. Please write it down. Okay, so what are the key lines, key words that you should definitely know? So this is a structured representation, you should remember. Okay, organizes measurable business events as facts, you should remember. Descriptive business context as dimensions, you should remember. And define the relationship between them. Okay, at least this much you should know. These are the key words that you should not mix it with. Making sense, everyone? Okay, so let's do some hands-on exercise, guys. You remember we had this Power BI? We will try to create a product table like this. So it's not a product table. We will basically do a pricing, basically price per product, that kind of table. So shall we do that? Everyone, please open your Power BI and open this, what we did last time. I hope people have saved it. Order sheet, people, and returns. Can you guys open? I'll give you a minute. Please let me know once you have opened it. Everyone. Okay, opened it. Okay, cool. So now what we have to do, if I have to do some kind of changes in the table, what I should do? How I will create something, guys? I told you I want to create a new table, right? A product ID table. So how I will go about doing it? What should I open? I basically need to go to, you can see here, Power Query. Okay. So can you please open Power Query, everyone? Yeah, okay. So I'll share my Power BI window. Can everyone now see it? Okay, okay. So what we will do, right click it and I will say duplicate. Okay. We will duplicate it. Now we can rename it if you want. Okay. So basically this is going to be a table where I want to create product and price, correct? So basically what I'm going to do is, I'm first going to check whether I have any distinct ID by which I can do it. You can see I have got something called product ID, right? And I also have sales. I have got profit. I've got quantity. So if I basically want to find price, it will be what? Sales by quantity. Okay. So how you will go and open? Okay, I'm going to show this once more. In home, can you see there is this use Power Query editor? So I have to press transform data from there. Okay. Simran, is it clear? Okay, so now I can come here. I will go to transform data and I'm going to do group by. Okay, please press advanced. in group by. Here we will select what? We are going to select the product ID. Okay. Now we are going to do some aggregation. So what will be the aggregation? So we can basically do total sales. So I'm going to do sum, which will basically be what? For by sales. Then I add another aggregation, which is going to be total quantity, which is going to be sum, and this is going to be by quantity, right? How many of you have done this? Okay, now plus, okay, everyone. So here you have got, I've got product ID. You can see I've got total sales and total quantity. Can you see that? So now I can actually add a column, correct? I can do a custom column. What will that column be? Unit price, which is what? Total sales by total quantity, correct? Now I can go here, transform this as fixed table, unit price as fixed table. Now what we will do? How we will close this, everyone? So we will do close and apply, okay? So how do I know whether the table has been done? You can see here it's loading. Can you now see I've got a product price table? You can see this, guys. How many of you have completed? Please raise your hands. Okay. So after add column, Simran, I have basically changed the name of that column and have basically inserted a formula, which is I have selected total sales divided by total quantity. Then I have pressed OK. Are you following, Simran? Anyone else who's having any query? So I can delete this table. I just done a table. Okay. You can see I can delete it from the model. I'm just deleting it. I can now go to order sheet, if you see, and I can actually delete some columns. What are the columns? I need to keep product ID, but I can remove category, subcategory, right? If I want, I can remove all of this. Product name. So I am fine. I can actually delete them, right? Now using product ID, I can connect them. So let's see that, how to do that. So come here to relationships, guys. Can you see this? So let's move this. We had created this relationships yesterday, correct? So you can see I have a fact table in between. Now I have got another fact table called product price table, right? So how we are going to connect these two tables? I'm going to take this product ID. I'm going to link to this product ID, okay? Okay. Okay. So ID, you can see there is some issue with this table. Okay, you can do a many to many relationship and we can save it. Everyone. Done. Ideally, this should be a 1-2 mini. So I'll just check it during the break. I think it's 7:55. Let's take a 10-minute break, guys. Okay, clear? I'll just check what is the issue. Okay. So we'll take a 10 break. Okay, we have basically created this product price table. I have renamed the table as product price. Okay. So guys, let's continue. Okay, so here what did we find? We found that this product price table had duplicates, correct? So now what we have to do? We basically have to go to home here again, go to this view, table view, go to home. We have to remove duplicates. So we'll use Power Query and check it. Okay. So let's go to Power Query. You'll see that it's going to open again. Okay. We're going to select this product price table. So basically they are saying that it contains duplicates, right? So what we have to do? To select the whole table. Now we have to go to remove duplicates. Okay. Making sense, everyone? Suppose we are not clear, okay? So let's do one thing. So what we can do is we can do a group by if we want. We can we need to count rows. Okay, so how many rows are there? 1894. Okay. Just give me a second. Let's just check. Okay, so let's check for duplicates. How we will do that? So we know that there are 1894 different things, right? Then you go to transform. You can see statistics, guys, here. So can you see we have count values and we can have count distinct values. Let's check that. So 1862, right? So we have 1862 here. Okay. So you can see there are duplicates, guys. Am I clear how we did that? Okay, so this gives us an idea that there are duplicates, correct? So now let's do, now we go to transform, group by. So we can do product ID and we can basically count here. So basically, we should use this to count duplicates. So 1894. So 94 minus 62 is what? So we got around 32 columns which are duplicates. So based on this column, we can do. So what we can do? We are selecting the whole table and we can say remove duplicates. Okay. Now let's see. (1962). Okay. So there is one product ID which is basically okay. So you'll see this later, guys. So basically, there is some error with this product ID. So the best thing we can do right now is we will go to transform home and we can say that we will remove duplicates. Okay. Ideally, we shouldn't do this, but I'm just checking. Okay. 1962. So you can see these are similar. So there were 32 rows which are having duplicates. So you just removed that. Okay. So just for our purposes, now we'll do a close and apply. Why? Because we're going to use this as a dimension table. So it should be a one-to-many relationship only. Okay, that's our goal. Am I making sense, everyone? Now you can see I have got this. I go now here. I have to definitely link product ID here with product ID there. Okay. Now you can see I have a one-to-many relationship. Correct? Then I will say okay. Am I making sense, everyone? So now you can see, right? I have created, you can see now I have created a product price table or a product table. This is right. Let's rename this. So we will go here and rename. So let's call this as a product table. Okay. So I've just named it as products. Can you guys create another table called customers? Is it possible for you guys to create a table called customers? How will you go about doing that, guys? How will we do that? Suppose I wanted to create a table called customers. How will we do that? Are you guys there? Am I audible? Can you see my screen? So yes. So how will you create that? I'm going to give you guys 10 minutes. Please create that. How will we do that? It's a dimension table, right? So basically, go back to Power Query, create a duplicate of that table orders. Now you will do a group by customers. Okay, so after customers, you will have customer name. Then you can have state, city, pin code. So how we will do that? Sorry. You go to home. Here is the Power Query editor, correct? So basically say transform data. So now let's do a duplicate of this. So we'll rename it as customers. Okay. So now we go to transform group by, go to advanced. So here we will say customer ID. So you do customer name. You can select country. You can select state. Select postal code. Actually, we don't need country, just one country only, right? So we can basically have region. Okay. So let's say okay to this. So we can rename as or we can just go back. Okay. So I've got this. You can see I've got customer ID, customer name, state, postal code, region, and number of products that they have bought. No, I'm creating a dimension table. That's why I'm creating by grouping, right? So I'm trying to show you how a dimension table works. No, that's why I've done that. Am I making sense? So the table that we had, no, it is not ideally a good star schema. So I'm just showing you how you can create it. Am I making sense, everyone? Okay. So I've got a table like this. So now what we can go to home. We can do close and apply. So now you can see I've got a customer table now, right? So you can see it's automatically related to people, right? Can you see that? So I also want to yeah, okay. I will link it like this. Ideally, we should have deleted this here and then we can link it like this. Am I making sense, everyone? So I want you guys to explain what again? So I'm just teaching you how we create a star schema, right? So what I have done is I am creating another dimension table. Just give me a minute. Switch on my power. Hardly any. Just a minute. Huh? Oh. So is it clear, everyone? What is confusing? What is confusing? Everyone, are you following what we have done till now? Okay, so let's go to our. So you understood, right? This is how a star schema works. We try to recreate this. Okay, currently we are having a fact table, but it has got everything, right? So we basically were trying to reinvent the wheel. Okay, we were doing some deconstruction, but we had duplicates. Okay, so the idea was just to show you how a dimension table will look. So a product table will have basically product name, a product ID, okay, category, subcategory, description, basically, and it might have the unit price. Okay, so I was just trying to deconstruct that for you. Is it clear, everyone? Okay, so we have created this product table, we created a customer table, right? Now we found that we could not absolutely create a star schema. There were duplicates and things, right? So this is what happens when you are not starting correctly. That is actually what we are trying to say. So yeah, so guys, the reality is that conceptually to do something, we have to definitely work again and again and again. That's why IT is high paying, because it is not like it cannot be done in one go. We have to redo it, check it, clarify it. We have to do sanity checks. We have to do specific checks, right? So you can see that since we did not start correctly, what happened? We could not actually achieve a star schema, or we have achieved a star schema, but there were some redundancies, right? We actually had duplicates, which are also called as redundancies. So you found that the better way would have been if we had actually created dimensions. We had one fact table and we could link it very well, which is exactly what Ralph Kimball is saying. This is basically how a data warehouse should look. Clear, everyone? Okay. Now, if you ask, right? So in a star schema, it is always a, from dimensions to a fact table, it is always a one-to-many relationship. That is a speciality. And that is also the check. Okay. So why is that so? Because that's how it basically happens in nature, isn't it? So whenever you are creating when you have a number of products, right? You are going to create many versions of one product only. So in a fact table, you might have the count of the product, isn't it? Am I making sense? Yes. So attributes are called as dimensions. Okay. So region is an attribute. It is also called as a dimension. It can be used as a filter or a slicer, isn't it? So the questions are the facts which are captured by the fact table. Okay. And the correctness or the accuracy of these facts are going to depend on the structure. Am I making sense? So your facts are measurable business events. For example, I'm finding out the total sales. I'm finding out the number of customers. I'm finding out how many customers have ordered more than 5 items in the past 2 years. Okay. So this is a question which are aggregation of facts. And what will be the dimensions? Basically, I'm looking at past 2 years, right? So 2 years is becoming my dimension in this. Am I making sense, everyone? Relationship is how we have linked these tables. Clear? Okay, you might say that, okay, fine, this is a table. Is it actually going to be used even today? Yes. So if you look at this particular philosophy, you will find that even in modern databases, modern platforms, this particular way in which we are creating BI, right? Business intelligence exists. So it is very much in work even today. So you can see that in Excel, what happens in Excel, we created a pivot. So in pivot also we had a filter, we had rows, we had columns, isn't it? So we had the same logic as what we have just explained in Kimball, right? Look at Power BI. Again, we have a star schema, isn't it? In Power BI, didn't we have a star schema? Do you guys agree or not? In Power BI, we are using a star schema, isn't it? Yes. So anyone has used Tableau? Is there here anyone who has used Tableau? So what is Tableau? Tableau is a drag and drop kind of platform. Okay. So in Tableau, what happens? You are basically will select your dimensions and you will basically select your measures. Okay, automatically. So that also is Kimball effect only, right? The same definition that he has given. How many of you have heard this word snowflake? Raise your hands. If you have heard this word, can you please raise your hands? How many of you? You've heard? Only one person has heard. What about others? So people, you guys should hear snowflake, because what is snowflake? This is nothing but all your online data, right? Netflix, how does it work? You basically have content on the cloud. You are accessing data on the cloud, right? Azure is what? You have data in the Microsoft online servers. You are accessing it, correct? Yes, OTT content, yes. So anything that is in the cloud is basically, the platform is called as a snowflake. Okay. Now, even if I look at snowflake, what I will do, I basically will create the structure and then only I can understand, what has happened. If I do analytics, what is analytics? So OTT, what will happen? Let's say you are doing Netflix. So what kind of analytics I will do? I can look at the number of titles. I can look at number of customers. I can see how many customers has seen this title. I can map it. I can see how many minutes they have watched for the content, right? I can do an average of that. So all of this basically is what? It's the same Kimball methodology, isn't it? You have one fact, then you have got different dimensions. So here one dimension is the contents, different titles. Another dimension are the customers. And you can see I am creating a fact table on that, isn't it? Am I making sense, everyone? So I can do this and one day, in one particular time like this, isn't it? Are you understanding this? Okay, why is this slide important? Because they can ask you in your interview. That's why the slide is important. Okay. Then anyone has heard about Databricks? Has anyone heard about Databricks? Databricks, you can see, is online for big data. Can you see that? So Netflix is big data because of the quantity, right? But suppose you are having banking data, financial data. So they are going to use something called as Databricks only. Okay. So this kind of big data, then again, you will have a star schema in the BI layer. If you use BigQuery, what is BigQuery? Suppose Amazon is there, no? Amazon is nothing but cloud data warehouse. So again, you will have a logical modeling. Again, the same logic that Kimball has said. Then MongoDB. MongoDB is what? When you are basically having internet kind of data. So it's no SQL database. Here also we will basically be modeling our analytics. So same logic that Kimball said works. Then you have paraquet or ORC data. These are basically different format, columnar data. Okay. Here also we have the same facts and dimensions and logical relationship. This is how you can measure or create analytics. Am I making sense, everyone? So no matter what platform you are going to use, they do implement Kimball to a certain level. So what has changed? So what has changed, guys? So let's understand how it works. You can see here, you have a lot of online data. So you can see there is a Google or SaaS platforms are there, YouTube, right? Can you see? Then you have this cloud data. You have got many other data points, right? You can see this. So these are all the data. So this data you can see, I basically have got on the cloud, that is the server is somewhere else. So this is one server, let's say this is another server, this is another server, okay? This is another server. You can see I basically have got data from different. This is an API, okay? So in reality, this is what you will be doing if you become a BI engineer. So you're going to get data from all these servers. Then you will process this data. What is data processing? Basically what we did in Power Query, isn't it? So basically you might transform the data, you might clean the data, you might create new dimensions, right? You might basically take a subset of the data, or you might basically populate the data. So what is an example of populate? Suppose you have the pin code, okay? So basis that you can basically find out which area this person is living. Okay, so what happens is you have something called a socio-economic areas. So it's possible for you to find out whether this person is residing in a rich area or in a medium income area or in a poor area. And based on that, today you find there are a lot of studies, no? They say that Zudio is opening shops in these kind of pin codes. Correct. So this, all of that is what you are creating, or you are populating this kind of data. So this is all data processing. After you do data processing, you can do machine learning. So machine learning, what you can do predictions, right? And once you have done those predictions, you can actually convert that into a report. Everything today can be done online, isn't it? Do you agree or not? Everyone? Do you agree or not? Right? So this is the updated definition of data model. A data model is an abstract representation. Why abstract? Because no longer we are talking about a server. No longer do we have to create these tables in a server or in our computer. We are basically doing it conceptually, isn't it? And we are defining how the data is structured, related, interpreted across different layers. So it does not matter whether it is sitting in my computer or it's sitting in many computers or it's sitting in the cloud. I can still do this. So this is the new definition of data model. Please write it down. A data model is an abstract representation that defines how data is structured, related, and interpreted across storage, computation, and analytical layers. This is the modern definition because today we are using cloud. So we don't basically own the data. The data is not sitting on my end. It might sit on, let's say, an AWS or a Google Cloud or someplace. How many of you are with me? How many of you understand this? Is this making sense? Would you be able to answer in an interview if someone is going to ask you about what is a data model? How does it apply to this data system or big query or big data? Will you be able to answer? Everyone is confident? Please raise your thumbs if all of you are confident. Is there anyone who is not confident about this? Is there anyone who's not confident? Okay, so let's now even go to today LLM. So what is happening in today LLM? How do you think this data model is useful for LLM? Why? How do you think data model will work for LLM, brother? Any idea? You know LLM, right? So we basically have this big models like ChatGPT, uh, Claude, then you have Gemini, isn't it? How do you think it works there? So here what happens is this data model again it's very important. Why? Because if you are feeding this particular model a lot of data, it should understand that which of this data are parameters, okay, which of this data are context or filters. So for example, when you are writing ChatGPT, that please create a Disney kind of animation, right? You are writing a prompt, right? So in the prompt, what are the things you are specifying? You are specifying certain context. So you're saying, I want a Disney type anime or animation, right? And I want a castle, right? So these are all what? Objects. Okay? Am I making sense, everyone? Or you might send an image to it. So what the particular chat GPT has to do? It has to deconstruct this image. It has to identify context or filters which it can apply, right? So the bigger filter is, Disney type animation, or it wants a Japanese types anime, okay? Or it wants a Ghibli type of animation, right? Am I making sense, everyone? If you do not give this context, what will happen? This LLM will not be able to proceed. Either it will give you some hallucination. What is the hallucination? When it doesn't know what to do and it keeps on repeating itself. LLM, just like us, will never basically agree that it is wrong, no? So that we call it as hallucination. Am I making sense, everyone? How data models also work in LLMs, is it clear? Similarly, LLMs also have something called as RAG. What is RAG? Basically, in RAG, it is actually going to get data or files or a combination of both. And this is going to give context. Okay. So this again, you will find that it needs to have the modern definition of data models to do all these functions. Am I making sense? Why data modeling is very important? How it is used in LLMs, how it is used in cloud services, how it is used in data warehouses. Are you clear, everyone? Is there anyone who's not following this? Raise your hands, please. Anyone having queries? So all of you will be able to confidently speak about this in your interviews if at all you are probed on this. Yes? Please give a thumbs up if you are very clear about this. Okay, so now we will just start with DAX because we have done one part of it. Okay, I'll just start with DAX. So what is DAX? DAX is data analysis expressions. We defined it that day, right? So it is not a formula. It is not SQL. It is not a thumb rule. Okay. So again, if you look at DAX, basically it could be based on rows, it could be based on columns, it could be based on a combination of conditions also, which we also called as query. Okay. So let's do a very simple thing which we have already done, which is called as a calculated column. We did calculated column, right? We have already done that. What do you understand by a calculated column? What is a calculated column, guys? What is a calculated column? Anyone? We did a calculated column, correct? So let's go back here. You remember we went to this order sheet. Come here. Didn't we do this? We did some flagging, no? Did we do some flagging? Okay, I can't see the flagging. Okay. Okay, so let's create a new one. So you can see I have created something called as unit price. What is unit price, guys? So unit price is nothing but total sales by total quantity. It can be created by division, addition, subtraction, multiplication, anything. Okay. Basically, we are selecting two columns. Okay, row by row it calculates and it stores along with the table. That is called as a calculated column. It is not a single item. For every row it is calculating, no? And it will be stored along with the table. Am I making sense, everyone? I think we calculated another column, which I cannot find actually. Anyways. Is it clear what is the calculated column? If you remember, we calculated if profit is less than 0 and discount was 0, then we basically had marked those columns, right? If you see, that is a calculated column. Am I making sense, everyone? What is a calculated column? So a calculated column is where you find that these calculations are not only done, it will be stored along with the table. Okay, clear? Okay, so I think we are almost at time. Anyone having any questions or queries? So how many of you found the concepts that we basically thought is practical and it is useful and interesting? Please raise your hands. Because I had specifically devised today's session for your interviews. Okay. So if you find that this is very difficult to follow, maybe we'll just stick to normal BI. That's why I'm taking this understanding. Okay. Would you like more sessions which would be useful for your interviews? Or you want to stick hardcore to BI only concepts? What about the others? There are some 140 people. I have got only 5-6 people raising your hands, right? Okay. So with this, we will end the session, guys. Okay. And tomorrow we will start with DAX. Okay. We've already done some calculated columns. We'll create more columns tomorrow. Then we will do measures and we will do, filters and many things more. Okay. So tomorrow we will start with DAX. So please come prepared. So people who are buying your new computers, do install BI, do everything that we have done till now and come prepared. Okay. I think attendance was already shared. Amar, can you please share it one final time?
Yeah, sure, ma'am.
All right. So guys, with this, we will end the session here. Tomorrow, we will do more calculations. So please come prepared, okay? It will be a hands-on session. All right. Bye-bye. All right. See you guys tomorrow. Bye.